Hello, so now we're going to be talking about the types of sets. To start with, what is a set? And as I've explained before, a set is a collection of well-defined objects. For example, if I say what are the number of people in a class, or a class is made up of students, and I say there are 5 students in a class, 5 students in a particular class, and I list out the names of those students as Ada, then Ima, Dayo, Femi, and Daniel. So now this set of the number of students in a class define the students that are in this class. In this case, we have 5 students. So the members of a set are called elements, and by members I mean the objects that are contained within the set. So in this case, Ada, Ima, Dayo, Femi, and Daniel are all members or elements of the set. For example, if I say a set A is made up of vowels, then I know I'm talking about what? That the set contains alphabet A, E, I, O, U. So the alphabet A, E, I, O, and U are referred to as elements within the set. So now we start by looking at equal sets. So what does it mean for two sets to be equal? Two sets are equal if they contain the same elements. So if you look at this example where you have A is equals to 1, 5, 7, and 8, and you have B is equals to 1, 5, 7, and 8, you can see that the elements within these two sets correspond to each other. That is, they are the same. Therefore, we say that these two sets are equal. Or write A is equals to B. Now let's talk about the concept of empty set. A set with no element is referred to as an empty set, and it is denoted as empty square bracket or 0 with a slash on it. Now to explain this, consider a set of square with 6 sides. Now you know that a square only has 4 sides, so therefore you can never find a square with 6 sides. So this set is an empty set. So you can do it as this or this. Another example of an empty set can be the set of men taller than 3-story buildings. Well, you know that this is practically impossible because you cannot be that tall. So now when you know that no element can fit into the definition of the set, we say that that set is what? An empty set. So this is also an example of an empty set, a set that contains no elements. What about the universal set? This is the set containing all objects or elements and of which all other sets are subsets. So what does it mean? When I mention the word universe, what comes to mind? What comes to mind is, as the universe is the founding matter in which every matter in the universe is contained. For example, in the universe you have the sun, the stars, you have our planet. So in the same sense, the universal set is like the biggest level of set in which all other subsets or smaller sets can be extracted from. For example, this of a universal set, I can say the universal set is equal to the set of students in a school. So now the set of students in the school is made up of what? All the students. So in this sense, I can extract, for example, the set of students in a particular classroom, or the set of male, or the set of female. Those smaller sets in which I can extract from this are called subsets. So the universal set is the set that contains all elements of which in which I can find other smaller subsets. So what is the meaning of subset now? Is set of which all the elements are contained in the universal set. It is denoted by this symbol. So as an example, if I say the universal set is all alphabet from A to Z, to my universal set I'm defined as all alphabet of A to Z, and I say A is made up of vowel letters, my alphabet from A to Z will be A, B, C all the way to Z. and my vowels are just made up of letters what? A, E, I, and O, and U. So I can say that A is a subset of the universal set. And why is that? Because the elements of A can be found in the universal set of alphabet A to Z. So the idea of superset is just the opposite of subset. So superset refers to a set in which a smaller subset can be removed. So in the example that we talked about U being equals to all alphabets, and we talked about A being the set of vowel numbers or vowels. So now, and we said A is a subset of U. So in the same sense, we can write that what U is a superset of A, meaning that in U you can find all elements that are A in U. So that is what we mean by the superset symbol. So as an example, if A is equals to 1, 3, 5, 6, 7, 8 and B is equals to 1, 5, 6, we can say that A is a superset of B, meaning that all elements in B can be found in A. Now let's move on to the idea of the complement of a set. This refers to the elements that are not contained in that set but are in the universal set. So let's first start out by considering our usual examples where we say let U is equals to the set of alphabets, and we say, so we know this will range from A to Z, and we say that A ranges from what? Our vowel sounds, which are just A, E, I, O, and U. So now we want to find the complement of A, which is written as A raised per C or A prime. So the way we do this is that we consider all elements that are not in A but are in the universal set. In this case, you know that our universal set contains all letters A to Z. So the complement of A will be all letters in this universal set that are not contained in A. So A is contained in, say A, so we don't write that out. We write B, we write C, we write D. We don't write E because E is contained there. We have F, G, H. We don't write I because I is contained there. J, K, L, M, N. We don't write O because O is contained there. Then P, Q, R, S, T. We don't write U because U is already here. V, W, X, Y, and Z. So the complements of A, these alphabets here, are what are not in A but are in the universal set. So a simple example would be if U is equals to 1, 5, 6, 7, and 8, and B is equals to 5, 6, and 7. So I know that the complements of B in this case will be the elements that are not in B but are in A, and in this case only 1 and 8 are in the universal set but are not in B because 5, 6, and 7 are also here. So we don't write those out. We only write the ones that are not in B, which is just 1 and 8. So the complement of B is given as the set of 1 and 8. So now let's move on to the idea of finite set. A finite set is a set that has a finite number of elements. So a set in which I can count the number of elements in it is referred to as a finite set. For example, the number of students in a class is an example of a finite set because I can know for certain how many people are in a class. The same thing goes, for example, the set containing the word population. Now I can count everybody living in the world. It might be a very long thing to do, but it's very possible. So this is also an example of a finite set. How about infinite set? So an infinite set is a set that is not a finite set. That is, you cannot count it. For example, the set of all integers. Now what are integers? Integers are whole number for, and they range from what? Minus infinity, then up to 1, then 0, then 1, and it ranges also to what? Plus infinity. So it ranges from minus infinity to plus infinity, and infinity means it has no end. So nobody knows how many integers we have. There is no value to it. So that is an example of an infinite set. Also, the set of all real numbers is an example of an infinite set. And to explain this, a real number are numbers that lie within the number line, and if you remember the number line, you have your 0 here, and here you have the negative axis. -1 can have -2, can have -2.37, can have 1, you can have 2.53. Any number at all that you can think that lie on this line is referred to as a real number, and you would notice this number is also infinite because nobody knows how many real numbers we have. So these are examples of infinite set. So finally, we'll be talking about disjoint sets. So two sets are said to be disjoint if they have no element in common. So for example, if we consider these two sets 1, 2 and 3 and 4, 5 and 6, we can see that the elements in all of them are distinct, so we say they are disjoint sets. However, on the other hand, if we look at this example where you have 1, 2 and 3 and 3, 4 and 5, we can see that there is one element common to both of them, which is this 3. This 3 is common to both of them, so this is not a disjoint set. So this pretty much sums up the types of sets that we have, and in the next module we'll be looking at how to perform set algebra.